Okay, so logarithms is one of those topics that students usually have a lot of questions about. It's sort of a weird concept. So I wanted to start by talking about exponents because they're kind of related. So 2 to the power of x is equal to 8. So if I gave you that problem and I said 2 to the power of what gives me 8? Okay. Well, you'd say, x there would need to be 3, right? Because if I did, let's write it over here, right? 2 to the power of 3 is 2 times 2, which is 4, times 2, which is 8, right? We've got 2 times itself 3 times, right? And that's what gives us 8. Okay, so that one's not so bad. Now, if I gave you 2 to the power of what is 32? Okay. You'd think for a minute and you'd say, okay, well, how many times do I need to multiply 2 by itself in order to give me 32? Well, let's try it. So 2 times 2 times 2, we already figured out that 3 things is 8, times another 2 gives me 16, times another 2 gives me 32, right? So that gives us 2 to the power of 5 is 32. So the answer here would be that x would have to be equal to 5. Okay. Now I'm going to skip a line here, but let's go down, and if I gave you 2 to the power of what is 64? Okay. Then you'd say, well, 2 to the power of 5 is 32, right? We did that one up here, right? So if I multiply that by just one more 2, so 2 to the power of 6, that would end up giving me the 64. Okay. So this is all well and good as long as we've got sort of nice things where it's 2 to the power of a whole number, then that gives us an answer, right? But if I gave, let's say, 2 to the power of what gives me 40, okay? We know that it can't be 2 to the power of 5, right? Because 5 gives us 32. And we know that it can't be 6 because 2 times 2 times 2, 6 times gives us 64. So if I want to figure out what this x is, that's when we kind of get stuck, right? We know it's going to be some number between 5 and 6, right? 5 is too small and 6 is too big. But other than that, we're kind of not really sure. So we're going to take this relationship here, the 2 to the power of x is equal to 40. Okay. That's what we call or I like to call it exponential form. Okay. And we can take that and rewrite it a little bit. Okay. So rather than saying 2 to the power of what gives me 40, instead we can write that log base 2 of 40 is equal to x. Okay. So when I read a log, what I do is I kind of think to myself, let's do a thinking bubble here. I think 2 to the power of what, right? What number gives me 40? That's what I think. When I see log base 2 of 40, that's what I'm thinking in my head. 2 to the power of what gives me 40. So I would call this thing here logarithmic form. So maybe we can color code this a little bit. So this number here, right, that is the base, okay? And same thing over here. This 2, whatever number was in the base, that is still the base, okay? Now let's pick a different color here, something totally different. How about green? Nope, green is bad. Let's go with purple. Okay, so purple, this now here, this x is the exponent, okay? And that's going to end up over here on this side of the equal sign. This is actually the exponent, right? Remember, a log always asks you 2 to the power of what? It asks you to find the exponent. Okay, and then last but not least, let's choose a different color. Yellow maybe? Hopefully this is okay to see, right? So this 40 is sort of the answer, and that's the thing that's going to go inside the log. Okay, so we can rewrite something back and forth between these two forms. Let me blow this up for you a little bit more. There we go. Okay, so a few things that I kind of want to note about logs generally, just because it kind of comes up every once in a while. So a couple of notes. Okay, so I just want to state explicitly here that we can convert back and forth from the exponential form, right? Remember that was this thing over here, right? We can convert back and forth from exponential form to the logarithmic form. Okay, right? So we can go back and forth between exponential form and log form. So if we see it in log form and we don't like it, we can rewrite it this way. If you see it this way, you can always rewrite it that way. They mean the same thing. Okay, the second thing that I want to take note of is log base 10 of x. Okay, that's one of those where if the log is of base 10, okay, it's often written as just log of x. So they sort of just forget to write the 10. So on a calculator, when you see that log x button, it's really by default taking the log base 10. It's not written, but it's sort of assumed that it's there. The other sort of common log base that comes up, okay, is log base e. Ugh, what is e? Let's sort of just remind ourselves. Remember e here, right, is that special mathematical constant 2.71 something, 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 something. And it comes up all the time in math. So if we want to do log base e, right, we will have some number and we want to know, you know, e to the power of what gives us that number. It's going to be usually written as ln of x, right, which some people would call the natural log. Okay. Or some people will say ln x, your choice. Okay. Okay, so last but not least, we can only take the log of positive numbers. Okay. And let's think for a second about why that's true, right? Remember, if I were to think about that, let's go back to 2 to the power of what gives me that number, right? So if this was a negative number, right? So let's make it -8, right? If I gave you log base 2 of -8, right? There's no number that I could pick here for x that would end up giving me a negative value, right? If I were to sort of think through all the values, 2 to the power of 1 is, actually, sorry, let me move this down a little bit. Let's think through all the different values, right? 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8, right? If you were to keep going higher and higher exponents, they're just going to be bigger and bigger positive values, right? But if I do 2 to the power of 0, oh, that's a common one that kind of comes up. What is that defined to be? 1, right? Any number to the power of 0 is always 1, okay? Now, what if I did -1? Right? Remember back to your rules, we would say that that would be 1 over 2 to the positive 1. So that's 1/2. That's still a positive number, right? 2 to the power of minus 2 would be 1 over 2 squared, which is 4, right? So it doesn't matter which direction I go, all of these answers here, right, are always positive numbers, right? So here, this number here can't be a negative number, right? Because none of these answers here are negative numbers, right? So if this doesn't work, right, then neither does this. Okay, let me just move this over to make it a little bit prettier. Okay, so we can only take the logs of positive numbers.